Hello, Eric. I hear you.
Okay, that's good then. All right.
Uh,
Okay, so today I welcome everyone once again to Geospatial Developers. And today we'll be looking at some flow controls, some functions, and then some, maybe probably if we have time, we'll look at loops. Yeah. So I'd like to start from, and one other thing, we'll look at inputs also. I'm actually going to start from inputs. Okay, so when we talk about inputs in Python, we are talking of how to accept an input from like the client or from the system. So more like usually you have forms and then you input your data into a form and then your data goes into a database or goes to do something. This is the same way. In that same way, we want to be able to allow the client or whomever that is behind the system to be able to input some form of information into Python, and then from there we can do further processing with that information that the person entered. So for us to be able to take inputs, Python has a keyword or a method called inputs. So this input allows us to be able to take input from the clients. So I can give it a text, a string to define what I want to do. So I can say put some data here. So I've defined an input, but we also learned about variables. So we are saying that variables allows us to be able to keep our values within a defined name, so that whenever we call that name, we have access to our values or our outputs. So I give this a variable name called imp. Now, what I want to do is that whenever the person gets the data, I just want to print out the information that the person will put in. So I'll say you should print the imp. So you can open your command prompt. When you open your command prompt, you can navigate into the area where you have your file. So you can do something like CD, and then you come into your area where you have the file. So if I have my file over, I can put this folder in here. So I'm saying CD, you should go into this folder where I have my Py file. You click enter. Once you are there, you can type Python 3, and then you call the file name. That's Python.py. So I have a command over here. Now the system is telling me to put some data here. So I just put jet. Now after inputting jet, it gives me jet over here. So let's try some string formatting. I think last week you used some form of string formatting, the upper and the lower. So I'll write everything in lower text and then I'll use the string format to change everything into an upper text. So you can do dot upper over here. Now when I come back here, I can do and I have everything in caps down here. So this is we and then with inputs Python. Okay, so that's basically with inputs. So we are getting data from the clients and we are using it for further processing. So we can look at flow control now. So when we talk about flow control, we are talking about how to manage the flow process of our logic or of our Python statements within our script. So let's say I want to say something like, and when we are talking of the flow, we are talking of if-else conditions. So we have the if, we have else, and then we have elif. That's in Python. So we can say if, let's say if Jed should print is the name is Jed. Else, let's come down here and print. Let's just say his name is unknown. So let's print this and see what we'll have. I have to comment these ones. Let's run this. So once I run it, usually when you have if and then you have exchange, automatically it is always going to take the condition as true. So it is always going to run the first process. Now if we want to make it dynamic, we can say here should be equal to, let's say name. But we've not defined name, so let's define name. We say name should be equal to, let's say ed. Ed, right? Now let's see. So if name is ed, it's going to include name equals to Jed. Now we have his name is unknown because ed is not equal to Jed. So we are managing the flow of our script using the if-else statement. Now there are times that you have multiple expressions that you have to run against. So if there are expressions like that, we use the elif. So we come here, we say else if, say name equals to, let's say Kofi. I should print his name is Fidel, and then we get cups. Let's say we have multiple ones. Come down here. Let's say Kofi Hammer can. Yes, Sarah. Let's put here Sarah and then put here. Okay, so let's say the name should be Sarah then. Alright, when it goes through, it comes to the first condition and then it will check. So if it's saying check if the condition is, or the condition is true or the expression is true, if it is true, then comes into this block code and then execute whatever that is within this block code. So it checks if name is equal to Jed. So it checks if name, the name over here equals to Jed. Hold on, its name is equal to So it checks if name is equal to Jed. Now name isn't equal to Jed, so this block of code isn't going to be executed. It comes here, and this elif over here is just a short form for else if. So elif is saying else if the name equals to Kofi, then it should execute what is over here. So when it checked, it says okay, it is false. So if it is false, we shouldn't come down here. Let's go to the next condition and let's see if that condition is going to be true. So all it's going to do is that it's going to look for the condition that is true, and then it is going to execute the rest of the code within the that particular block of code. So till we reached Sarah, it came to Sarah, and then it realized that, oh, name over here is equal to Sarah, and it equates to Sarah. So then it executed this block of code over here. So it then executed the block of code over here. So we use this else. This else is only going to run if all of these expressions over here are false. So if the if is false and the elif is false, then it will run to else. So else is the last answer that is going to pick should these ones, the if and elif, be false. So the else, in a nutshell, the else is going to run whether true or false. All right. So that's with the flow control. That's something little about it. I'll do further readings later on. The next thing we'll look at, which should be loops. So when we talk about loops, we are talking of iterations. We looked at it when we're doing JS. So loops are just iterations. So we want to say that we want to do something over and over and over again. And then we want to do something over and over again. And there are two types of loops. We have the for loop and the while loop. That's in Python. We have the for loop and then the while loop. And you this. So with loops, we have the for loop and then the while loop in Python. So with the for loops usually we use the for loops when we know like the number of iterations to make, like the iterations that we want to go through, or the loops that we want to run is definite. Then we want to say, okay, then we are using the for loop. So for this specific number of times to do this. Then we use the while loop when we don't know the number of loops or the loops are indefinite. That's when we use the while loop. So let's try a loop in Python. We can say for each instance of for each let's say 1, 2, 3, 4, 5. Let's add 6. What you want to do is, so also to bring attention to it, you realize that usually the block of code comes after a column. We have this indentation coming after the column. We have this indentation over here. We have the indentation coming after the column. When we started the for loop also, we have a column over here, and then what follows next is an indentation. So usually the indentations always comes after a column. So when we are defining functions, and the column comes, then the next thing is an indentation. And in Python, the indentation is generally 4 spaces. So if you have it over, you can do 1, 2, 3, 4. Then you have your indentation. That's generally, but you can also specify your own indentation. So whichever indentation that you choose, it should run throughout your work. So you have over here the tab size. So mine is 4. Once you change it to 2 or to 3, it will give you, it will automatically give you like a 2 indent or 1 indent or 3 indents. So you realize that the moment I click enter over here, automatically it gives me a 4 indent. It is because I've set the tab size down here to 4. Let's try 2. Let's see. You realize now my indents have changed to 2. So I want to change it back to 4. Good. So that's something little about the indentation. I think we did that last week. So this is the for loop. I'm saying for each instance of the objects within this particular array should do something. So let's just print each of them. So let's comment these ones out. Let me have them running ready. Then let's run this. So we have each of the values in here running. Now this is a for loop. So basically this is a for loop. You have a definite number of iterations to do. You use a for loop. Let's look at when we want to use a while loop. Now, how a while loop, we want to say that we'll say, let's just give a to be equal to something like 0, and then we want to say while a equates if I do that stop 1, so let's just say, let's give it something like 20 is too much, and just give it 5. So you're saying while a all right, it should be 0 rather. Let's say while it is less than or equal to 5. We want it to do this. We want it to print a. Then with the while loop, because we don't know the number of iterations, we don't know like the condition. So usually we use the while when we want to say that if a condition is true, it should do this process till the condition is false. So the loops also runs in the same light. We are saying if a particular condition is true, then it should continue running these iterations. So we are saying it should do this if the condition is true, but because we have to come out of this condition by getting to a false expression, we'll have to create an exit button over here. So we do that by saying we would like a to increment by 1 and to be equal to 1. So once we run this, let's run this and see. Let's comment this out. Now let's run this. So we see a. So we are saying once a is less than or equal to 5. Of course, a is 0. So we are saying once 0 is less than or equal to 5, it should print the 0. After printing 0, now it should let 0 be equal to plus 1. So what I did over here was a plus equal to 1. I could have done, it should let a should be equal to a plus 1. So this is the same thing. I did it the other way around. So a should be equal to a plus 1. So I'm saying 0 should now have a new identity. That identity should be equal to 0 plus 1. So anytime it runs through, it will add plus 1. So the first one was 0, it added 1, and then it came here. While 1 is less than or equal to 5, it should print 1, and then it should add 1 to 1, making 2, and it did that for the rest till it was equal to 5, and then now it's broke out of the condition. Now there are times that we'll say while true, it should keep on doing this. Now there's no way to break out of it, so you have to set an exit. So usually it should be since here we are saying here is true. If along the line this changes to false, let's do here true. Let's say we are saying should print. Let's just print this. So once this is true, it is going to be printing yes until this becomes false. then it is going to change. So whenever you set a while loop and you don't set a break function to stop the while loop, what's going to happen is, I think I explained this in the JSA, you realize that you have your memory running low because there's going to be the release of values into your RAM, which is going to fill up your RAM. Your system is going to become slow and then slowly go off. Okay. So that's with while loop. That's with the while loop and then the for loop. Now, also, when you are dealing with the for loop, we have the break and then the continue. So I can say it should print each, but it should check if this each. So what we are looking at now is the break keyword. Then after the break, we'll look at the continue keyword. So the break keyword is saying, okay, go through the function, but now I'm going to set a break. I don't want everything. I don't want the whole list of objects to be gone through. So I want to set a break. So I must set a condition within the iteration so that when that condition is met, then we can stop the execution of the loop. So that's what the break does. So I'm saying if h is equal to, let's say 5, then it should break. Okay. Okay, so let's run this and see. So you realize my loop ran till 5 and then it broke the function. It didn't print out the 6. Now with this break, there are times that we'll have a nested list. So we can have, let's say, should print each, and then we'll say, let's say for A, B, in. Let's write C. We want to keep here to the C. Now we are printing each, but we have AB over here. So what is going to happen is that it is going to break only the inner function, but the outer function should keep running. So let's print. So what we have over here is what we call the nested loop. We have a loop within a loop. Pull this up. So I have 1 and then I have AC to AC. Oh, let's say should be C. Okay, C then B rather. So we have ABC, 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 ABC. Okay. So I'm printing it first. Okay, let's print this. let's use a, let's see. Okay, so we have it over here then. So you realize even though the break is within, we have a break in here, it only breaks the inner function, but then the outer function runs till it gets to 6. So the break, based on how you want to write a function, it is going to break the inner function or the outer function based on the condition that you are actually looking at. Okay. The reason why we are saying if it is A, it should break is that we are printing A. So the first time it goes through this function, it prints the A. After printing the A, now it checks if the A equals to A, then it breaks it. So it doesn't go through the B and then the C. I think that should do. And then we have, let's comment this, we have the continue. So we use a continue when we want to say that, okay, we have an iteration, we are going through the iterations, but should a condition be met, then what we want to do is that we don't want to continue running the rest of the code that is within that current iteration. So it should just continue running the rest of the iteration without running the rest of the current code. Without running the rest of the current code. So what I'm trying to say is, so we are saying should print each one. We are saying if h equals to, let's use 3, so that we don't have a lot of, let's put our continue here. Should continue. And that is continue. I want to print. Let's say just print good. Let's put this good line. Okay, let's run this. So we have 1. So when it went through 1, we printed 1, and then the next thing we are saying if the condition is met, which is if the instance of the object within the list is equal to 3, then it should just click continue, and then it should just continue. It shouldn't run this. So because it's run and it was 1, this condition is not met, so the continue isn't run. So we have our good over here showing the 2. The condition isn't met, so it printed out the good. But when it was 3, we realized that the condition was met, so the continue worked. So it's saying that, okay, continue with the iteration. Don't run the rest of the code over here for this current iteration. When it came to 4, we realized that it printed a good. So that's the difference between the break and then the continue. The break will break your iteration. It will prevent the loop from running, but the continue allows you to continue running the iteration, but it doesn't allow you to run the rest of the code for the current iteration that is on. That's the current one. Right. So we've done inputs, we've done flows, we've done loops. Let's look at functions now. Let's go on this side. So what are functions? So now in our normal day-to-day activities, we have, even in our job places, we have these responsibilities. We have functions, we have tools, and then these tools have functions. So whenever we want to do something and the need for a particular tool arises, we go get that tool and then we use the tool for what it has been created for. That's the same thing with functions also. We want to create tools, or we want to create scripts or statements whereby we'll call them whenever we want to use them for something specific that we've stated that they should do. So functions are just we can say I don't want to use the word callables because using the word callables is somehow doesn't bring it down to a layman's view, but that's the understanding, what they call it. So these functions are callables. We call functions and then they execute a particular statement which executes or performs a particular function. Yeah. So functions are just to do some things, and we have anonymous functions and then defined functions. So with functions we have defined and anonymous, and then we have anonymous functions. Now, defined functions are functions with a defined name. So we use the so to define a function. We start with the def word. I don't really know what it means. I always assume it means definition. So I want to create a function that is going to print maybe I am eating. So let me name it eat. So I'm saying whenever somebody calls eat, I want to print I am eating. No, so this is my function. So like the two, it is created, it is there. So if I want to use maybe a spanner to unscrew or to unwind the bolt, I just go and pick the spanner. So it's the same thing. Because I want it now, I call it. So once I call it, then I run it, then I am eating. But until I call this function, which makes it a callable, it is not going to run. Okay. So that's it for functions. So this is an example of a defined function. We use the def word and then we give it a name, and then we state what we want our function to do. Usually functions break with the return statement. So we should return this. But for some reason in Sublime Text, it's not going to print out the return. Usually it brings out the return here. So let's do print. I don't know if it's only with Sublime Text. Let's print this. So we have the I am eating. So whenever you state the return breaks your function. It tells the function that, okay, we've ended the function. It shouldn't run through these statements again. So return is saying you are going somewhere now, return, stop doing whatever you are doing. Then we use that to break a function. Okay, so with functions, with these different functions come with arguments. And with the arguments, we have position arguments, and then we have keyword arguments. So the positional arguments are the arguments that their values, the values for the arguments are assigned to those arguments based on their position. So we can have define eating. So we'll have an argument A, and then we'll have an argument. Let me just say here should be the name, and then here should be the food. Now I want to say should print. Let's use a string format over here. Should print the name. And we say this. Put this over here. Now let's call this. Let's call this out. Let's see. So I have Z is sitting right. Now, if I change these values, it is going to give me an output that I'm not interested in. If I put right and put Z over here, you see right is sitting Z, which shouldn't be the case. So because I have name over here, because these are positional arguments, if you put the name over here, it is going to look for where the name is within the function, and it is going to put the value for that particular argument over there. So whatever I put over here is what is going to be used in here. And whatever I put over here is what is going to be used over here. Now I can take the same function and then change it into a keyword argument and say, so here I can say, here should be equal to food. Food should be equal to rice, and then name should be equal to Z. Now I have Z is eating rice. So I realize that I've changed the position, but now I'm using keywords to let the script know that, okay, let food be equal to rice. So the position doesn't really matter. It is going to look for food, and wherever food is, it is going to put rice over there. It's going to look out for the name argument, and wherever the name argument is, it's going to put the value Z over there. Okay. Now in functions also we have what we call arbitrary arguments. So the same way that we've written these arguments, we might want to write some form of arguments, but we don't know the number of arguments. We might want to write a function, but we don't know the number of arguments that might be needed for that particular function. So let's say we want to write a function that prints out names, right? So for arbitrary arguments, we start with the star over here, and then we say, let's just put names. When I come here and say for a names, I want to print names. So forgive me, the dots are so print names, and then we can have Z over here. We can have David. So let's run this and see. So you realize we have our names being printed out over here for us. We have Jed, and then we have David. We have our names being printed out. So this is a form of an arbitrary function, arbitrary argument with the functions. So you would use something like this when you are getting a list from somewhere, but you don't know the length of the list. So the same way we use the input, your input can take a list, but you don't know the length of the list. So you use this function to get each of the instances of the objects within that list, and then you can use them for whatever you want to use them for when you get there. Okay, so I think that's that. There's also the keyword one. So it works in a similar way, but that's with keywords. So with that one, you use a double star. Use a double star over here, and then when you are with that one, use a double star over here. But now it's going to be maybe A is going to be Z. Then we have B is equal to. So it is going to flow throughout like that. So the same way we did the keyword earlier on over here like this. something similar. So I want to move to the anonymous functions. So anonymous functions, the difference between defined and anonymous is undefined. So anonymous functions are functions that do not come with a defined name. Yeah, they are functions without a defined name. So with anonymous functions, we call them lambda. So we start with lambda. The next thing is our argument. And then after argument, we call the semicolon. Then what we have over here is our expression, what we want it to do. So with this, we say let our argument be x, and then we want to say, okay, for whatever value we put over here, we want to multiply it by 2. Now let me put the lambda into a variable so that I'll be able to call it whenever I need it. So I do AA, use AA. So let me use dd is equal to the lambda. So then I say dd into brackets. Let me put 5 over here. So let's print this out. So now my lambda is giving me 10 because when I call dd, what appears is this lambda expression, and then this 5 is going to be replaced with the x over here. So we are going to have 5 times 2. Now with the lambda also, we have what we call mapping. So the mapping allows us to do something similar, like something similar to the arbitrary arguments that we used over there. So with this same lambda, I can call map. Whenever we call map takes in a function, and then it takes in a list. So this is a method already defined in Python. We are just using it. So we have map function and then keyword. Now our function is this dd. So you put dd over here, and then let's get a list. You can say our list should be 1, 2, 3, 4. Now if we use the map like this and we just do print map, we are going to get our output, but it is going to give it the output in a binary manner. So it's going to give us our output. You see, it's going to give us a map object, but we want our map. So it's going to give us the map object, but because it's a map and we're multiplying these by these 2, what is going to happen is that the output should be a list. So we call the list around it, and then when we call the list, we cast the list around it. It should give us our output. So now we can see 1 by 2 is going to give us 2, 2 by 2 is going to give us 4. We have 3 by 2 giving us 6, and then we have the 4 giving us 8. So this is an example of the lambda, and then using arbitrary arguments in there also. So if we read up functions, I think let's look at classes then. So we can call it a day. So we have what we call classes. So when we talk about a class, we are talking of the blueprints for creating objects, and objects are objects. Objects are the instances of a class, and classes are blueprints for creating an object. So you can have, when we have a is equal to something like a is equal to, let's say a is to, I like using my name. This is an object over here. So you an object comes with an attributes. Objects have attributes and the behavior. So that's the definition for an object. Objects are objects or an indicator to show that something is an object. It should have an attribute and then it should have a behavior. So we have parrot. A parrot is an object. The reason why we are saying parrot is an object is because parrots can sing, which is the behavior, and then parrots have attributes, which can be maybe they are green, they are yellow, based on their color. Let me bring this down a little bit. So let's try and define a class, and then we use the class creating an object. So to define a class, we call the class keyword, and then just say, let me name this animal. So I've created my class, and then whenever we define our class, and then we give it our class, and the next thing is that we usually have what we call the class attributes, and then the instance attributes. Class attributes is when we do something like, so animal, we can say what species are they, we want to look at. Let's look at my mouse. So we have this as a class attributes. Then when we come down here, we want to look at the instance attributes. So instance attributes, we initiate it by using the init, and then we call self. Then we say, let's get the name. Let's get the name. Okay, let's just do name for the beginning. So we do self name should be equal to name. So what we have over here, we call this the instance attributes. Okay, so let's look at how this plays out. Let's create a method, and then this method is what we term as the behavior. So define a method over here. What should we give it? Animals. Let's say mammals. So let's see what. Let's just say when you program, we just print these types. These types what? So now I want to call this class and create an object out of the class. So we can do obj as our variable name should be equal to animal, and then we want to, okay, let's say animal. So let's try and see if we can get the attributes of the class attributes. So we call obj, when we call obj, we get the class animal. So we do dot. We do double underscore, then we call, let's access the class. After accessing the class, we want, let's see if we can get a species. Then we want to see, let's put here name to be, let's see, we'll just put that, let's see. Then let's print the objects obj dot the name. After printing obj dot name, let's print, I think that is already going to print. Anyways, let's use print. Let's do obj dot walk. Let's comment this out. Let's run. of species. Animal has no class. obj.name print obj. It should be limited to a class. Dot what? Take 0 position argument. So, obj dot what takes 0 position argument. Let's write out this. Let me deal with this one first. Okay. So we have the animal here, we have cow here. So what happens is this cow over here comes into, okay, let me explain it this way. So anytime we call this animal, which is what we've done over here, anytime this animal class is being called, the first thing that runs is the init. This init stands for initialization. So it initializes the arguments you put over here. So for any time you call the class for the first time, the first thing to run is the initialization. And then the instance attributes, usually they are dynamic. They are dynamic because based on the instance that we are using at the particular, like we have students in the class, they want to get each student's name. So we have something like name over here. So because we have different students in the same class, when we are taking their name and we call the name, you have Jed as an instance, we'll have maybe Jerry as an instance, we'll have Ishmael as an instance. So they become dynamic. But with the class attributes, it is private, it is internal. So it runs for all. That is why we have the mammals over here. So the mammals is going to run for any time we call the animal. This class is internal as an attribute and it's going to run. So one thing is that we humans will breathe. So if we are looking at the class for humans, the internal class attribute should be an attribute can be breathing because each and every animal breathes. So it's going to run through as a property or an attribute of humans. It's going to run through all. But because the instances may vary in relation to our name, we put the argument over here to make it dynamic so that we can, based on the instance, that particular instance. So, and when we talk about instance, we are talking of the points within which the class is being called to create the object. So that's what we have over here. And then, so the instance we call the name, and then we have this over here. Now this work, I don't know what I'm missing. I'm forgetting something. Let me read the error again and see. If anybody knows what I'm doing wrong, you can just let me know. Object is not defined. Let me take this out. Here, let's see. Object animal. Facing on name. Oh, sorry. I didn't initialize it itself. Yeah, stop. I always forget this thing. Yeah. Okay, so let me try and do a little bit more explanation. So we use a self. So this init becomes our constructor. It's what allows us to actually construct the different instances that are being used to create the object. And then this self over here talks about this particular instance. So in JavaScript, we use this, and this just talks about like this particular instance or the current instance within which the object is being created. So all the attributes we have over here, or the statements we have over here, is going to be in relation to this self, as in this particular instance of the class. So it wouldn't affect any other instance of the class. Yeah, so I think our time is due, so I'll end here for now. So the floor is open for questions. If you have any questions, you can bring it on board. Then we answer them together. Okay. So I'm saying with the init stands for initialization, and whenever you call the class, the first thing that runs, or your first line of code that runs is the init. It initializes the class. So based on the attributes you might put over here, some might have, some might not have, it is going to initialize it, and we call that the constructor. So it is what helps you to construct your object. So, and we are saying the init also works along with the self. The self should run through anytime you define a class, and then you are defining methods under the class, you add self, and then the self is saying that these methods are in relation to this current instance of the animal. So an example of what I was saying is that multiple people might be accessing the same animal. And if multiple people are accessing this animal, the self is just saying that, okay, for this particular person, this instance, every attribute is affecting this. So even though multiple people may be using the same class, whatever dynamic argument they are putting in here, as in the instance attribute, it is going to be in relation to them, that particular self of the class of the animal. It is not going to affect the other instances of the class. So it isolates the attributes of the class to a particular instance. I'm hoping that is much clearer. No, you can't have multiple inits within the class. You only have multiple inits when you are doing inheritance. So, okay, let's see. So we have what we call inheritance in relation to classes. So animal. Let's see. Let me create another class called, let's just say frog. And then I'm telling frog to inherit animal. So down here, I define my init, my name itself. Okay, let's see this. Let's just give it maybe color. So, and that's giving name. Let's just say so. That's the should be also. I do this. I do super. Then I go init. Then okay. Let's just leave it this way. Let's do x1 should be equal to 4. Open this way. Just use the name now. Let's bring objects 1. Let's see what happens. Should it be something? So it should have a name. Should it? What am I missing? Give me a second. I'm going to check this thing out. Okay. So you realize that what I have over here is I don't have work over here, but I'm printing out a work, and then it's giving me this type of work, but the work was defined in here. So that's an aspect of the inheritance. So this is inheritance in Python. So what it's doing is that we are inheriting the methods that have been defined, the methods and then the attributes that have been defined in here within the animal. And then we are saying we want to get all of these, and then we want to inherit it into the frog so that we don't retype or redefine all of the methods that we might have defined earlier on again. So Python has a rule that says that dry, meaning that you should not repeat yourself. So dry don't repeat yourself. So they try to minimize functions that have already been defined. You don't have to redefine them again. So the inheritance allows you to be able to get those functions from the upper or the parent class. So this becomes your child class. Now we have init being defined over here, and then we have init also being defined over here. The difference is that we are saying that whenever we call frog and it is going to run for the first time as an instance of the class, it is going to run the init first. So it is going to initialize this init for the frog. But because we are inheriting all of the attributes of the class animal, we call the init also over here, which is, so the super stands for the parent class, which is the animal. We say, and we are saying that it should initialize all the attributes of the parent class, which is the animal, to down here. So this is the only instance that you might need to call multiple inits within a class. But usually we only just call one init. If you are inheriting based on if you're inheriting, you recall the init of the parent class. Please, any other question? Sure, you're welcome. Please, are there any other questions, or it's okay with this one? All right, so if there are no other questions, I would like each and everyone would be looking at Django probably Thursday when we meet. So I wouldn't be able to teach how to create virtual environments because I use Ubuntu. So some might be using Windows and some might be on Ubuntu, others might be on Mac. So one thing that I'd want you guys to do is I think there should be some simple YouTube videos as to how to create a virtual environment. So you can either go to YouTube or just search on Google, create a virtual environment, Python. So you should get and whenever you type it, add the version. Either you're on Ubuntu or you're on Windows or you're on Mac, you add it so that you create a virtual environment. Then when we look at the Django. And if possible, also try to install the Django. So with Django, after creating your virtual environment, then you do the installation of the Django. But even if you're not able to install the Django, you can just create your virtual environment and then we can do the installation and we can start from the installations from there. It doesn't matter with the installations, it doesn't really matter the operating system that you are on when it comes to Django. But when it comes to creating a virtual environment, it matters because Ubuntu will give you different syntaxes or different codes for creating a virtual environment, and there will be different codes also for creating the virtual environment on Mac. So this should be a little assignment, creating virtual environments in the operating system that you are using on your computer. If it is Windows, how to create virtual environments on a Windows machine using Python. Okay. Please, any clarifications or questions? If not, then we can call it a night or a day. A night. All right, Ernest, please. I think we can bring the class to an end.
We've learned a lot today. Well, as I keep saying, let's keep practicing. So this is a build up to another thing, right? So after the Python, then we will jump onto a Python framework for web development called Django. So let's try as much as possible to understand the basics he's taking you guys through, so that when we start applying them, we wouldn't be confused. Yeah, so thank you, and let's stay in touch. If you have any, just put it on the platform. And I would also like to thank all those who frequently help friends on the page. Forgive me for not attending to some of these things on time, because for the past 3 weeks I've been very hot, and I've been very hot. So I hardly come on the page to during the week to see the issues some of you are going through. But I've seen some colleagues are doing some great job. I can remember, I think I saw Kofi Mega Boy and one of those guy. Thank you very much for helping your colleagues. This is the culture that we want to propagate. Let's keep helping ourselves and we will all grow stronger. Thank you very much and have a great evening. Bye bye.
Yes, bye.